Okay, so as I predicted yesterday, it looks like we are tasked again with working on the radio device. So the problem for today is that when we try to run the update, we are thrown an error that says that there is no space left on the device. So we browse around the file system and we can see the file sizes and also directories. The only issue is that we are able to only see the file sizes, not the directory sizes, and that would be more important to us. So for the first task, we have to calculate the sizes of the directories and then return only the directories that have a size of at most 100,000 and sum all these sizes up. Now for the second part, we are given the total size of the device, which is 70 million, I guess, bytes, and we are also given the size of the update, which is 30 million bytes. So what we need to do is to find a single directory that after we delete we will get enough free space to run the update. So now to the code. Because the file system has a tree-like structure, my first idea was to use a depth-first search or a similar algorithm, and after I analyzed the input, I saw that the file system was traversed in a depth-first way. So we can start with the parsing of the input. To represent the file system, I created an enum called node that can have two values. It can either be a directory or a file. For this problem, we don't really need to store the name of the nodes, but it's still interesting to have it. So as before, I implemented the from_stir trait. So this function expects as input a single line from the history, the commands, and it will first split the line by space, and we will have the first item and second item. If the first item is the string dir, then it means that we have a directory and we initialize it, and otherwise we try to parse it as a file. So we try to parse it as a number, basically an usize, and return a file. To parse the entire input, we get the contents of the file and we split by the ls string. So I was thinking to split the entire input into chunks of only the outputs of the ls command. So then we map over each chunk and we split it into lines. Then we try to parse each line as a node, but there will be some extra cd command lines which we will ignore because the parse command will fail on the wrong lines, and we use a filter map that will ignore everything that will be returned as a none. And finally we skip the first line because that is an empty line because the input string starts with the ls string. Then I implemented a depth-first search function that takes as input the root node, the input from the file which is parsed. This is a mutable reference because I want to be able to change it, and then after we call this dfs method on the root node, this walk vector should be empty. And we also have as input the results, which will contain the sizes of the directories, and the function returns the size of the root node. So if the node is a file, this is the base case, we just return its size. Then if it's a directory, then we want to remove the first item from the walk vec, and this will represent the neighbors of the root node. So we have to call dfs on each node in the neighbors, and as I said earlier, the size of the directory is the sum of its children. So we compute the sum and then we add the size in the result because this node is a directory, so result holds the sizes of the directories. And finally we return the size that we got. So for the first part, I initialized the root directory as a slash, the walk vector as a copy of the input, and I marked it as mutable to be able to change it when dfs is called recursively, and a mutable vec that will hold the result. Then we call dfs, and finally we get the result. We filter it so that there are only directories that have a size less than 100,000, and we add all the sizes. For the second part, the beginning of the function is the same. We initialize the root node, the work list, and the result vector. Then we get the size of the root directory using dfs. Then we compute the available space as the total space minus the size of the root directory. Then we also can compute the required space, which is the update space minus the available space. Then to find the smallest directory that after we delete we are left with enough space. We can sort the result vector in ascending order, and we have to find the first directory that has a size larger than the required space, and we are guaranteed that that directory will have the smallest possible size, so we just return its size. Also, the main function, just in case you wanted to say it, here I just called parse input on the string that is returned by read from standard input, and then I called each part function. So yeah, this was the seventh day. I really liked the idea of having to use a depth first search in this way, and yeah, I'm really curious what other methods can be used on this problem, if there are any simpler methods. But yeah, if you want to try out the code or just look at it, you can find it in my GitHub repo. So yeah, thanks for watching and see you guys next time. Bye bye.